Good evening. Welcome to the QCIS channel. We're on this channel, you get a daily dose of science, technology, engineering, and math. My name is Leon Jones, and this evening, I'm going to talk about something that is very important, particularly if you are going into designing wastewater systems, water systems. But basically, this type of water system that I'm talking about is more or less sanitary or your sewage systems. And the component that I'm going to talk about tonight is what is a lift station and how is it used? Now, of course, lift stations are generally like pumps. I'll give you an example of something that I can call a lift station. It's a flush toilet. Now, when you utilize your toilet and you flush your toilet, it generally goes down into a pipe, pretty much PVC pipe, and out to your storm sewer. However, what if your pipe isn't in the ground? What if your pipe is 8 feet up? Well, you have to use a pump to pump the water up to go out of your facility. In fact, when I lived in Slatington, Pennsylvania, I was on the bottom floor and a pump was needed to actually pump up the water and the waste after you flush the toilet. Well, that's how a lift station works as well. Let's get into a definition of a lift station. Well, when we look at a lift station, we can call it a sewer lift station. It's basically an underground pumping facility designed to move wastewater from a lower elevation to a higher one. And your key components include a wet well, submersible pumps, and a control panel. Now, they are very necessary when gravity flow is no longer possible, saving deep and costly trench excavations. Now, how does the lift station actually work? Well, number one, you talk about collection. Well, wastewater flows downhill through gravity pipes from homes and businesses into an underground storage tank called a wet well. Detection. Flow switches on level sensors monitor the rising water inside the wet well. And once the water reaches a specific preset height, the system automatically turns on powerful sewage pumps. Then, when you have your discharge, the pumps push the wastewater upward and outward through a pressurized pipe known as a force main to a higher point, allowing gravity flow to resume toward a wastewater treatment plant. And then there's shutoff. They're check valves. What they do is stop the liquid from flowing backward, and the pump turns off when water level drops back. Now, what I'm going to do is let me get into some videos, and these videos are going to be used for educational purposes only. You're going to have explanation on how a lift station actually works. So, without any further ado, fair use. This is for educational purposes only. First, let's hear what the video says about a lift station.
In this video, we will break down exactly what a lift station is and how they work. As mentioned before, wastewater travels from a building or house to a regional collection site. It flows downhill through underground pipes. But this becomes a problem when it reaches a low point where gravity can no longer keep it flowing. This is where lift stations are critical. They are installed at these low points to pump or lift the flow of wastewater to higher ground, allowing it to flow downhill from gravity again. To get a better understanding of what goes on inside a lift station, let's take a closer look. When the flow of wastewater enters a lift station, it collects in the underground tank called a wet well. As the wastewater continues to collect and rise, the water level is measured by hanging sensors called floats. Once the water rises to a certain level, pumps are activated and force wastewater out through a pipeline called a forced main. For smaller sized lift stations, most pumps are submersible in the wet well, but for larger, more complex lift stations, the pump is often placed in a separate room from the wet well to allow for easier access and maintenance. Lift stations also contain an above-ground structure that houses other equipment to maintain proper operation of the lift station. Access into the wet well is locked off with hatches since the wet well system can be very dangerous. For any other questions about lift stations and wastewater solutions, visit www.stateindustrial.com to get in contact with us.
And, give a shout out to State Industrial about how these lift stations work. I work for the sanitation district for the city of Michigan City, and we have 44 lift stations, and your lift stations have to be maintained. Now, let me get into some more. As I share my screen, go back. And again, we want to get into some information on what is the purpose of a lift station. So let me, what is a lift station and what is the purpose of a lift station? Okay. So we're going to find something interesting. And this lift station is for source. So bear with me. Bear with me because lift stations are very, 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 very important. Again, let's get into another video, fair use, on how a lift station actually works. Fair use.
My roof's got a hole in it, call 291 Roof, Gene Roofing.
You may now kiss the bride.
Video will explain the purpose and operation of wastewater pumping stations or lift stations. To illustrate how this system works, this video will follow wastewater from its source, through the local sanitary sewer system, and to a regional wastewater lift station. Wastewater begins in homes and buildings when dirty water is sent to the local sanitary sewer system through a drain or toilet. It travels through the underground pipes, usually under the street, until it connects with the large pipes of the regional collection system. The wastewater flows downhill until it reaches a low point in the system where it can no longer flow by gravity. Lift stations are installed at these low points so that the flow can be pumped or lifted to higher ground so it can again flow downhill through the wastewater collection system. When the flow reaches the lift station, wastewater collects in an underground tank called a wet well. As the wet well fills, sensors measure the water level. Once the water level reaches a certain depth, the pumps inside the lift station turn on and force the wastewater out through a pipeline called a force main. The pumps shown in this lift station are submersible pumps. This is because they are located in the water of the wet well, similar to a sump pump in a home. For larger and more complex lift stations, the pumps are placed in a room separate from the wet well. This allows easier access and maintenance. Lift stations will often have an above-ground structure to house the other equipment needed to operate the system. Placing this equipment above ground allows for easy access for maintenance and repair. Because the wet well environment is so dangerous, access hatches are locked and monitored to prevent unauthorized entry. Once the wastewater is pumped out of the lift station, it continues through the force main until it reaches higher ground. From there, it can once again flow by gravity. Ultimately, the wastewater arrives at one of the regional wastewater treatment plants where it is cleaned to strict standards before being released back into the environment.
And I thank MET Tutorials for that video. These videos are for educational purposes only. So again, let's get back and let's go back and find out what is a lift station. And I'm going to give you some literature about it so we can understand. So the video is just presented. A visual of how a lift station for sewer actually works. So what I'm going to do is let's get into some other points of education. Bear with me. Okay. So I'm going to get into a little bit of literature. This is from the PDH Academy, and I'm going to talk about a little lift station design. And this is by Mark Ludwigson. It's PE, and I'm going to go over a little bit of it. And purpose and function of a lift station. Well, the purpose of a lift station is to transfer water through a pressure pipe to a designated discharge location. A lift station functions by storing a small amount of wastewater and using pumps to lift the elevation and pressure of the wastewater, thereby moving the wastewater along to the destination. Lift stations also help ensure the wastewater flows only in the forward direction and not back into the gravity sewers. Lift stations serve a critical role in moving wastewater, also called sewage, from local communities to designated wastewater handling facilities. So a typical wastewater collection system is comprised of private laterals and sewers or gravity sewers, say gravity sewers, that basically move the wastewater by gravity from each property to a local lift station. The lift stations then pump the wastewater to a wastewater treatment plant. You can see the figures. You have your private lateral, your manhole, and generally this is your gravity sewer. Now when your gravity sewer reaches a low point, it is pumped up through pipes called a force main and then to your wastewater treatment plant. Now, again, it is possible to design a collection system with only gravity sewers and no lift stations. However, the gravity sewers require a consistent downward slope. And as the sewer pipes get longer, the deeper down the pipes need to be installed. Larger deep tunnels can be utilized to collect and convey by the flow of gravity or by flow by gravity. That's to convey the flow by gravity. Now, these deep pipes are expensive to construct and are difficult to maintain. So basically, engineers utilize lift stations to allow for the conveyance of wastewater in shallow pipes of a smaller diameter. Again, engineers love to utilize lift stations so they can allow for the conveyance of wastewater in shallow pipes of a smaller diameter. Lift stations also provide flexibility in routing pipes around or over features such as rivers, lakes, mountains, valleys, landmarks, and sensitive environmental areas. And here you have a force main over a canal. Now, normally multiple lift stations will pump wastewater into a common force main pipeline rather than keeping the force main separate, since a single pipeline is more economical. The pipe size grows in diameter as it picks up the flow from additional lift stations until reaching the destination, which is often the headworks of the wastewater treatment plant. Now, in large collection systems, there may be a regional pumping station that accepts flow from multiple lift stations and boosts the force main pressure to convey the wastewater to the wastewater treatment plant. And it is also common to use the term master pump station or booster pump station. Here's an example of a network of lift stations shown right here. Here's your regional lift station, and here's a typical lift station. Here's your force main and your regional force main. Note how the lift station that is furthest from the regional pump experiences the highest force main pressure, 38 psi, and that is this one right here. As the flow needs to overcome the greatest amount of friction losses from the long pipeline and its many fittings. A computer model is typically used to calculate the pressure at each lift station, especially when the collection system is being expanded or significantly modified. So, of course, with lift station design, you're going to have regulations and industry standards. You also have a design criteria. And here's the design criteria right here. Now, the order of these design steps can be modified. So lift station design requires an iterative approach where an internal sizing and selection of components is assumed and then checked and modified as the design progresses. For example, after initial pump selection, the wet well volume, intake design, and discharge design should be checked. If any of these items change, the system curve should be modified and the pump selection checked. These interdependencies raise the chance of oversights and mistakes and make the final quality review of high importance. Calculations should be kept well organized to assist in this effort. So, the following sections provide a general guide to each of these steps. Additional guidance can be found in the reference document section as well. So, here you have your design flow rates. And here's some of your calculations. And when designing for the rehabilitation of a lift station or when adding a lift station to an existing community, it is helpful to measure the actual wastewater flow rate to confirm the ADF and PHF. This should be done over a long period of time, ideally a year or more, since wastewater flow often varies by the season and may peak during holidays or special events. Here you are looking at the following methods. You also have the types of lift stations. So the four most common types of lift stations. Number one, you have your submersible lift station. Two, you have your dry well lift station. Three, you have your suction lift station. And four, you have what we call a vertical lift station. And five, you have your vacuum sewer station. Now you also have your pump quantity Some small lift stations are typically designed with two pumps. There is one duty or lead pump and one standby or lag pump. Each pump is the same, and each pump can operate across a full range of flow conditions, including a peak hour flow. That's your PHF. Now, a duplex pump arrangement has the following advantages: simplicity in design, construction, and maintenance, lower construction costs, and the smallest diameter wet, and therefore the smallest footprint lift station. Using three or more pumps is beneficial under the following conditions: low flow rates such as a PHF greater than 5,000 gallons per minute, peak factor greater than 4, such as for CSOs. What's a CSO? It's a combined sewer system or combined sewer overflow. Michigan City has a CSO, and also the city of Mishawaka, there's also a CSO. And again, the force main pressure range is going to be greater than 20 psi. What's psi? Pounds per square inch. Three or four more pumps. They do offer the following benefits: ability to maintain the water level for variable speed control applications, ability to cover a greater range of flows and pressures, and it can still pump average flow if two pumps are out of service, and there's an increasing in pumping efficiency with associated energy savings. So large pumping stations, especially booster stations, may have a combination of small pumps and large pumps. The small pumps stay in the high efficiency range during low flow events, while the larger pumps can efficiently handle flows during large events. So this combination of small and large pumps requires a more complex control logic. Also, a redundant small and redundant large pump may be required. So it is unusual for local lift stations to be designed with a combination of small and large pumps. You also have your speed control. Your wet well design. And again, for variable speed pumps designed to hold a constant water surface elevation, the minimum volume can be based on providing sufficient time for pumps to start or stop. When a pump is started, the motor must be ramped to the desired speed, and the pump currently online must be reduced in speed. The time required for this is usually 1 to 2 minutes. However, experience has shown that having a storage time of 4 minutes provides an additional safety factor for unforeseen conditions and possible, well, basically potential drive control. And here are all of the equations. And I'm just going over the overview for you. This is more of design. Then you deal with your lining. Most wet wells are designed of concrete, which is generally resistant to corrosion. However, the wet well is designed to last the longest of all components in the wet well, as it cannot be replaced like mechanical or electrical items. So a coating or lining on the interior of the wet is essential to protect it from raw sewage and corrosive gases. A coating on the exterior is an option for protecting the concrete from corrosive soils and groundwater, as the concrete itself can have a alto-microbial admixture where superior corrosion resistance is desired. And here are the following types of common options for lining the wet well: plastic liner, high speeds epoxy. You have your intake design. Your discharge design. system curves. Again, most engineering firms have standard Excel templates or programs for calculating head loss values. The Hazen-Williams equation, if you have taken hydrology or fluid mechanics, is by far the most used formula for calculating pipe friction losses for pumping applications. Not only is it simple and easy to use, but it's also required for many regulatory agencies. So coefficients for friction losses and K values for minor losses can be obtained from flow of fluids through valves, fitting, and pipe by crane, Cameron hydraulic data by FlowServe, or other documents listed under helpful resources. And you have your pump selection. Here are all your examples. Here are your lift station features. Wet well ventilation, dry well sump, odor control, power supply, electrical equipment. Here's what your control panel looks like. Water supply. And here are all the references. But overall, when we go back and find out the purpose and function of a lift station, again, it's to transfer wastewater through a pressure pump to a designed discharge location. A lift station functions by storing a small amount of wastewater and using pumps to lift the elevation and pressure of the wastewater, thereby moving the wastewater along to the destination. Lift stations also help ensure that wastewater flows only in the forward direction and not back into the gravity sewers. So basically, lift stations serve a critical role in moving wastewater, also called sewage, from local communities to design wastewater handling facilities. So a typical wastewater collection system is comprised of private laterals. And what is a lateral? A lateral is just a pipe that comes right from your house. It's a PVC pipe that goes right into your sewage system. Sewer system is in a manhole. That's what a lateral is. And of course, gravity sewers. It's your manhole. Your sewer system is a gravity sewer. And your water moves through that gravity sewer by gravity from each property to a lift station, and the lift stations pump the wastewater to a wastewater treatment plant. And here's what it looks like. But overall, when we get into what a lift station is, it's basically a pump. Pump that receives water into the gravity sewer system. And once the gravity sewer system reaches its low point, builds up, sensors send that water to a force main, which has pipes, and you're basically pumping water up elevation to get it back to gravity and then out to the wastewater treatment plant. And then from the wastewater treatment plant, so my water goes out into a creek or a river. And that concludes this presentation on what is a lift station and how it works. If you like what I just presented, please comment, share, and subscribe. And here's where you can find me. If you are looking for some political and social content, check my main channel out, particularly on Tuesdays, right here on the YouTube platform. And the name of my channel is the 401 Talk Zone Radio Show. It's my main channel. You can also find me on X, formerly Twitter, Truth Social. You can also find me on Rumble as well. So for the 401 Talk Zone Radio Show, find me right here on YouTube, X formerly Twitter, Truth Social, and Rumble. And for the QCIS channel, you can find me right here on YouTube, X formerly Twitter, and of course, LinkedIn. And once again, I thank you for listening and viewing this content from the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. Till next time, my name is Leon Jones. I want you all to have a wonderful and gracious evening.